People were like, oh my God, AI is suddenly here, 2023, it emerged from nothing. It's not true. It didn't emerge from nothing. We've been on an exponential curve for years, I would argue decades. It's just that people never noticed that that was the case.
Well, thank you to everybody for coming here and for joining us today for our Institute's Insight Dialogue on AI First Companies featuring Daphne Koller. I'm Paul McCracken. I'm with the Growth Equity team here in Toronto, and I'm joined by my co-host, Nadeem Janmohamad. We have with us today AI pioneer and entrepreneur, Daphne Koller, and I will embarrass her for a little bit. This is a woman who has founded 3 companies in 3 decades, started the company that sort of like created massive open online courses and is now taking on probably one of the greatest AI challenges of all, which is drug discovery and development. In 2012, she created Coursera, which she has called a passion project, an online learning platform which brought online education to over 130 million people worldwide. In 2018, Daphne founded insitro, with the audacious goal of revolutionizing the drug discovery and development industry. Inside of insitro, Daphne and her team are applying AI to kind of understand the underlying drivers of disease. What makes a disease tick, systematically drill down to the base, find the drivers, and drug it and treat it in a way that's never been done before. And for those of you who don't know the drug discovery industry, as a fund, we've generally shied away from making big bets in the drug industry because the returns on capital are not very good. The risk, the failure rate in clinical trials is high. For every 10 drugs, that sort of go into human clinical trials, 9 fail. So when you do an all-in return on invested capital, it's not particularly good. So there's not only a vision around treating patients, but there's also a very interesting investment opportunity in the company that cracks the nut on this very large and important field. So with that slightly long-winded but necessary introduction, I'd like to welcome our AI pioneer and entrepreneur, Daphne Koller.
Thank you, Paul.
And so, given the history and the sort of very deep and distinguished career in academia, you could have made a life out of being an academic. What prompted you to sort of leave, become an entrepreneur?
So actually, you mentioned that I had done my postdoc with Stuart Russell, and that was actually a turning point for me because one of the first things, I'd done my PhD at Stanford. I wrote my thesis on the ability to use probabilities for reasoning about uncertainty, and it was all great. It was a very sort of in-depth thesis. It got me a thesis award, and then I went to Berkeley. Stuart took me to lunch my first month there and said, so if I gave you a team of really incredible undergrad programmers to work with you to implement part of your thesis, what would you have them do? And it was a genuine question. And I sat there completely flabbergasted because I'd never even considered that question. And when I did consider it, the answer was nothing. It was a beautiful conceptual framework with 0 real-world practical value. So that, I think, put me on a path where over time I began to have an increasing sense of urgency to make an impact, a direct, meaningful impact towards the lives of real people. And that led me towards machine learning, then applied machine learning, then machine learning in the service of computer vision, and ultimately machine learning in the service of biology and medicine. And it was at that point that I felt like I actually was doing things that would have the potential to have translatable impact, but I was completely unable to do that from within academia because we went and talked to some companies, for example, and we did some incredible work on machine learning for cancer diagnostics. And we went and talked to a bunch of diagnostics companies and said, hey, look, this is doing so much better than pathologists. Can you please use it? Don't give me money, just use it. And
what year now?
This would be in 2010. And it's like, can you please use this? And their answer was, do you have a product? And I was like, no, I have a paper, read it. And like, no, we don't read papers. We buy products. And there's no incentive structure in academia to build anything that remotely resembles a product that anyone will use. Grad students produce what I euphemistically call grad student code. It is the write once, use never. Beyond getting the first figure of your paper done and published, then you move on to do the next thing. And that's fine, because that's what they are incented to do. And if you want to make an impact on the real world, you have to actually build stuff. And so that was ultimately what led to my departure from Stanford in 2012, because all of a sudden the work that I'd done at Stanford on computer-assisted teaching really had hundreds of thousands of people using it within a matter of weeks. And I realized that that was an opportunity to make an impact at a scale and a pace that is unparalleled to anything that I would ever have in academia. So I left on what was supposed to be a 2-year leave of absence, and then discovered that having impact is addictive, so never went back.
Thank you.
So Daphne, if you could take us back to 2012, when in many ways the machine learning and deep learning era really hit an inflection point. And this idea of being able to sort of combine very powerful computing systems with machine learning algorithms and data, and really, combine those three sort of key components. Since then, it's now becoming increasingly apparent that the ecosystem has been on an exponential trajectory. And I'm just curious if you could, share your perspective in terms of what you saw back then, and how do you see this playing out on a go-forward basis?
So the thing about exponential curves is that they are very deceptive, because people tend to gravitate towards linear interpolations of the data that they see. So they look at where you are this year, they look at where you are last year, and you assume that the rate of progress relative to last year is going to be the same as what you're going to see next year. And exponential curves can stay deceptive like that for a long time, because they look flattish in the early years of their development. And so today, you have people who are like, oh my God, AI is suddenly here, 2023, it emerged from nothing. It's not true. It didn't emerge from nothing. We've been on an exponential curve for years, I would argue decades. It's just that people never noticed that that was the case. So in some sense, you might say that perhaps I had an advantage, because if you look at the timeline that Paul and I were just discussing, I left Stanford at the end of 2011, early 2012, just as the machine learning revolution was beginning. And for 4 years, I was basically buried under a mound of dealing with Coursera-related stuff that had nothing to do with AI, nothing to do with science. And so it was all kind of in the periphery of my vision, but nothing that I really focused on. And then when I decided in 2016 to start looking around, I was like, oh my goodness, machine learning, AI has just exploded in the time since I left Stanford. And so maybe I had the benefit of perspective that other people didn't have, because there was almost like this 5-year gap between the time that I left Stanford and the time that I came back and looked at this. And it was that realization that we were on that exponential curve that led me to realize that this was just going to be a huge thing. I don't think even I, frankly, estimated the scale of the exponential curves. That deceptiveness that I mentioned makes it so that small changes in the rate of the exponent, the base of the exponent, can give rise to huge deltas in terms of what you achieve in a given amount of time. I did not expect ChatGPT in 2023. I will be entirely frank around that. But it was clear to me that this was going to be transformative. And so when I looked around, I asked myself, where was the area where I, as an individual, could make the biggest difference? And I've done lots of different things in my career. I've done robotics, I did computer vision, but when I looked around, there's plenty of really excellent people doing, machine learning for computer vision. And could I be additive to that? Maybe. Would I be transformative? Probably not. But what I realized is that there really weren't a lot of people doing machine learning, AI in service of the life sciences, because those are two disciplines that very rarely does the same person have had the opportunity to learn both, and I've had that opportunity. So I figured this was a hugely important thing to do from a societal perspective, and one where I could have a disproportionate value creation opportunity. And so that is what made me go back to that. Now, of course, everyone of all of the big tech companies, all the big AI companies are like, oh, life sciences, biology, medicine is the killer app for AI. They're absolutely right. But I'm glad to say that I noticed that earlier. So.
Perfect. Thanks for that, Daphne. Just before we get into insitro in more detail, I'm just curious, just on this point about being on this exponential curve, I was just wondering if you could maybe help frame the power and the concept of this, having this sort of force multiplier effect, where you have computing that is advancing on an exponential curve, and then you've got the models that keep getting better and better and better on sort of a 3 to 6 month cadence even, but then you also have this data piece. Just that concept of combining these three and the force multiplier effect that you get. Like, what's your view and perspective on that?
So I completely agree that you do need all of that. Plus, I would say the last ingredient that you didn't allude to is the talent and the people who can take the data and the compute and turn it into the models are also an increasingly, unfortunately, limited commodity relative to the opportunity, to the magnitude of the opportunity in this field. But I think, yes, all of these are absolutely necessary ingredients, and I think people often underestimate the absolute criticality of the availability of data. So when you think about what the spark that ignited the machine learning revolution back in 2012, it was ImageNet, for my dear friend and colleague Fei-Fei Li. People are like, she just curated a bunch of data, but what that really did is it drove the ability to try ever more sophisticated machine learning models on the data, created both a training set as well as a benchmark that allowed people to just get better and better. Prior to that data set, if you look at the performance of image classification algorithms, they were slightly, and I say slightly, better than random. Post ImageNet, the increasing amount of compute and the increasing amount of talent that was drawn to try and solve this challenge problem created models that were better and better, drove the creation of larger data sets like COCO and others, and kind of created this virtuous cycle, but it was all sparked by this one thing. So when you think about AI in the life sciences, one of the challenges that has always been kind of the rate limiting for AI in the life sciences is the lack of availability of high quality data. When I started working in this field, if you had a data set of a couple hundred samples, you thought you were very lucky. And now we're starting to see data sets of hundreds of thousands, even millions of samples, depending on what you're looking at, whether it's humans or cells. It could be hundreds of millions. And that is finally enough data to actually train real machine learning models. Because that's one of the things that people don't fully appreciate is if you don't have enough data, simple models, the ones that you learned about in basic statistics, linear regression, random forest, all of those, they do as well or better than the sophisticated ones. It's only when you have enough data that the curves begin to cross and that you have the ability to build models that just keep getting better and better. They have, in professional jargon, more and more capacity because you have data to feed that capacity and continue to make the models better and better. Without the data, it just doesn't work. So whenever anyone in any industry says, I want to deploy the fanciest machine learning, deep learning to my problem, the first question you got to ask them is, what data do you have?
Thank you for that, Daphne. So, in the early days of when you decided to found insitro, what was the aha moment for you? Like, why did you pick this particular path?
So first of all, it was the fact that I saw that in parallel to the AI revolution that was visible to many at the time, there is a parallel revolution that I think is not quite as visible to the general public, which is that of tools in the life sciences that enable the creation of massive data at scale. Whether it's tools like CRISPR that allow genome editing to be done with very high specificity and in a very scalable way, single-cell microscopy, single-cell transcriptomics, all of these things, little bits and pieces, each not little, each of them is substantial in its own right, but you can start putting them together to develop increasingly more sophisticated tech stacks that really address that rate limiting factor, which is the availability or lack thereof of data in biology. And it was that led me to the realization that you could actually do real AI in service of biomedical data because you had the convergence of those two forces. So I think that was the aha moment. Now you could ask within biology and life sciences, why drug discovery? And I think that is a personal preference. There's multiple opportunities for AI in other parts of the healthcare system. Certainly one can build healthcare systems today, for example, that there's a lot of excitement around medical AI and the deployment of large language models around, interpretation of, say, electronic healthcare records from patients and so on. Amazing applications. I think they will be very impactful. 10% of that work is actual AI. 90% is about regulatory, go-to-market, selling into healthcare system, reimbursements, all sorts of stuff that is really, really important, and I have zero competitive edge in. So I decided to do something where 90% of the problem is actually developing really pushing the technology to its boundaries to the point that you can address that 10% success rate that Paul was alluding to, and only a small percentage of the work would go towards things like addressing complex go-to-market strategies.
So in addition to the technology, lining up, sort of when it came to raising money, you're obviously you have a profile that attracted a lot of money, but from the get-go, you had to think about and answer questions about, okay, what are the sustainable sources of competitive advantage here? The technology is changing really fast. There's lots of smart people. There's lots of money out there. You're all in on this, right? You said, I'm devoting myself to this. What was at the root of your conviction to decide I can build a business that is going to have long-term sources of value creation? What were some of the things that you were thinking about at that time?
So first of all, I'm going to divide this question into two. There is what made me want to do this and what made me think that there was such a source of competitive advantage. What made me want to do this was simply, it's a thing that needed to be done, and not a lot of people who could, in fact, take that on. I've often told would-be entrepreneurs that building a company is really, really hard, and you shouldn't do it unless it is a thing that you can not do. It's just, you have to have the sense of urgency. Now, what are those sources of competitive advantage that I think we have? First, I would say it's the willingness to make a major investment upfront in platformized data creation that gives you an increasingly large and hopefully increasingly valuable data moat. It requires that you attract people who are the best of their field in life sciences and the creation of and the tools to help with the creation of some of those data sets. And I was willing to make that investment. It's more costly. You have to build labs, you have to buy reagents and robots and all sorts of stuff like that. And you have to hire really senior, talented people from a discipline other than your own, and be willing to share with them the strategic direction of the company. And so that it was a fairly non-trivial decision, and a lot of other companies, at least at the early days, made a different choice. They were like, I'm a computational person, that's the only thing I feel comfortable doing, so I'm basically gonna build an entirely dry company. I'm gonna use public domain data, things that I get from pharma partners, because pharma has the best data. They don't. And they don't like to give it to you when they do. And so the decision to make that investment, despite the cost and time and money to do that, was, I think, one of the pivotal things. I think the other source of competitive advantage that we have that I've been really nurturing from the very beginning is the culture and the people. They go together, because people build the culture and culture attracts the people. And really being very thoughtful and deliberate about building a culture that brings incredibly talented people from multiple disciplines together and allows them to all have a seat at the table in strategic decision making and really creating something together. And I've seen multiple failure modes in other companies where in some companies it's basically one type of stakeholder leads the path and the others are kind of like support structures, support teams towards that. You don't get the best people when you basically define them as a support organization. And we built the company in a very different way, with a premise of, fairly significant parity between the sizes of the two organizations. Our R&D is 60% life sciences, 40% compute, and everyone genuinely has a seat at the table. Thank you.
Actually, Daphne, I'd love to build on this last point that you highlighted. So what was fascinating was that as you built the company, you focused on not only building the technology stack and investing years to build that, but you also thought about how do you bring together these two distinct and very different domains, people from the machine learning world and people from life sciences and biology. So I'm just curious, if you could help us think about, how did you set out to do that? How did you establish that culture? How did you put in, practices to sort of, as you say, enable this to be self-reinforcing? How did you do that? And part of the motivation for asking the question is to not only understand how you did this, but how should we think about, as we continue to evolve in the AI era, we need to start to think about other industries that need to begin to intersect with AI. We as an organization need to evolve as well. And so we just would love to hear your perspective on this.
So I will say it's not easy. So think of it like a seesaw, right? It's very easy for it to become unbalanced and out of equilibrium. So you constantly have to balance and dance to keep the balance. And it's not just two types of constituents, because we have software engineers and automation engineers and clinicians. And so there's constant balance to be had. And so we constantly have to, as the organization continues to evolve and grow, have to try and maintain that balance. But there were a number of things that we did at the beginning that I think were absolutely critical to having the right conditions to even try and stay balanced in this way. First of all is a set of values that we laid out on day one, which involve very significant sort of two of the values really have to do with creating together a group of diverse individuals coming together to create together, by which we mean not only that we solve the problems as a cross-functional team, we define the questions as a cross-functional team. And we find that when you put people in the room before the questions have been defined, they come up with better questions, not only better answers. And some of the most creative things that we've done came from a question that emerged from this type of cross-functional dialogue that wasn't one of the ones that we had set out to solve to begin with. The other one has to do with how you engage with each other. And so one of our values is we engage with each other openly, constructively, and with respect. Each one of those words matter in terms of engaging, not being siloed, open to naive questions as well as naive proposals. So if someone asks, why don't we do things this way? The answer is, why don't we do things this way, versus that's the way we do this, so, go away. Constructively, because you want to solve the problem better, not because you have to be the smartest person in the room. And respect for what everyone brings to the table, so you don't end up with these failure modes where, you have scientists who sometimes think about, the computational people, those are the ones who fix my laptop when it breaks, or those life scientists, those are the ones who sit in the lab and pipette. You really have respect for the intellectual contribution that each and every group brings to the table. And then the other thing that we did, which is admittedly a non-trivial exercise and one that we constantly have to keep working at, is that all of the work that we do is cross-functional, is in cross-functional teams. We just had a really interesting discussion over lunch about the two extremes of the approach, of the spectrum that don't really work. One is that you basically, for example, take computational people and embed them in, say, in our case, life science teams, and they end up being subservient to the strategic direction and guidance of someone who's really not an expert in their field. And as such, they don't end up constantly learning and growing and really thinking like long-term about technologies that can be built. Or conversely, you take all of the tech people, you put them all in one organization that's separate from everything else, and then they end up building really cool technology that often doesn't serve the needs of the organization. So what we've done is people do report functionally, so life scientists get to learn from really talented life scientists, and similarly on the computational side, but all of the projects are cross-functional, involving people from multiple different relevant disciplines. There's a tax to that. It's a real tax. You no longer get to do hierarchical reporting, so a manager no longer is in control of all the resources that they need for their project. So there's a lot more wrangling and negotiating, if you will, for how do you prioritize different initiatives. There's more meetings where you have to keep people up to date across multiple different reporting chains, if you will. I would far rather pay that tax than any of the other approaches that we've discussed.
Thank you. And Daphne, in terms of the platform that you set out to build several years ago, and you're still building,
Yeah.
can you maybe just describe, what went into that? What were you able to leverage from the ecosystem? And then on the data piece, what's been the investment there?
Yeah, so this is a great question. So the platform that we've built has multiple different pieces. There's the laboratory life science piece, which is our data printing engine, if you will, which is taking different pieces of technology from elsewhere in the ecosystem. We did not invent CRISPR. We did not invent induced pluripotent stem cells. We didn't invent any of that, but we had very judicious decisions on which of those were innovative enough to really push forward our agenda of data that's fit for purpose for machine learning without being so far out there that they are just, frankly, academic papers that once you start implementing them just don't work at scale. And there's plenty of those papers that just don't reproduce when you try and onboard them into a real environment versus you cherry pick the one experiment that you can put in figure 3. And so that was a very significant bill to make the exact set of decisions that we did. I'm not sure we did the full optimum, but I think we made some pretty good choices. We have another piece having to do with onboarding of clinical data because, as Paul will tell you, one of the things that makes us relatively differentiated in this ecosystem is that we really bridge between cellular systems that allow you to test out causal interventions in a very rigorous experimental setting, but also bridge to what it would take to translate those findings into a human, which is often where a lot of those lab results break down, is that you're not closing that, you're not bridging that chasm. So there we are leveraging the best of breed of data sets that have been, by and large, generated by others. And then, of course, on the technology side, we are grateful beneficiaries of some of the open source code that's been made available by others. So, for example, Meta has done a particularly good job, for example, of creating and putting out their open source code for computer vision, also for natural language, but that's less relevant to us. And we often start with that and then recognize that, for example, image software that was trained to recognize cats and dogs and airplanes on web data is a reasonable starting point for looking at images of cells or of MRIs, but it's rarely the best answer. And so how do you take that and then build upon it to get to the best of breed for things that are relevant to our specific purposes? So that interplay of taking what's best available outside and then supplementing it and fine-tuning it to the needs of the application is really critical.
Got it. Thanks, Daphne. I'm just wondering, were there historical parallels that gave you inspiration at the time? Like, as an example, I sort of think about other big platform companies. Amazon set out to do online retail, and they sort of had to do it from first principles. Google did the same, with trying to organize the world's information. NVIDIA did the same with parallel compute. So I'm just curious, as you think about, how you built this platform, it hadn't been done before.
It had not.
So where did you draw inspiration from at the time?
So that's a great question, and I think so the companies that you mentioned were definitely an inspiration to us, but in a somewhat indirect way, because what we've built is not really a parallel to what they've built. None of them kind of set out with a purposeful view to generating data that is fit for purpose for machine learning. That's not what they ended up doing, although ultimately a lot of them ended up gravitating towards that. So Google does actually curate a fair bit of data that drives its machine learning engines. But what really gave me confidence about that was it gave me an answer to the question of what makes you think that you can build a new generation of biopharma company? And why do you not think it's a better strategy for you to just go and be whatever chief data officer for big pharma? Everyone was looking for one of those at the time, and do it with all of those resources and all of the data that they purportedly have and so on. Wouldn't that be easier? And I didn't, and there were two reasons for that. One is that I felt like the cultural transformation that would be needed to take one of those incumbents and really create a true seat at the table for the computational people in a way that runs deeply counterculture to how the companies have been organized, rewarded. It just would be an incredible uphill battle to try and re-engineer those companies from the inside. And then coming back to your examples, when I looked at those, you realize that the big giants that emerged as part of some of these truly transformative revolutions that we've had in the past, very often, or I would say even more often than not, did not come by a internal transformation of one of the incumbents. Amazon is not Walmart reimagined. Google is not the Yellow Pages reimagined. Netflix did not come from blockbusters. I think you really need to, I think you're actually much better off, even though it's a longer and more painful journey, building a company on the right foundations, AI first.
Yes, actually, and it sort of helped. I can't help but think of one of the things Jensen actually said last week at GTC was, when describing NVIDIA, he sort of said that, we are not, we don't take share, we create markets. We are a market maker, and I can't help but sort of really think about your company in that light as well.
Absolutely. So if you look at the majority, again, not everything, but the majority of what big pharma actually does, a lot of that is everyone playing cluster ball around the same very small set of targets that have been validated, and they do, better formulations, somewhat better whatever tox profiles. And I'm not dismissing the value of that to patients. I mean, one can always improve on such an important product as a drug. Very, very few of the drugs that came out of big pharma in the last 30 years have truly gone after innovative targets. I mean, frankly, even the biggest blockbusters that we see today, the ones that everyone talks about, the big leaps in, the GLP-1s for obesity, it's a 30-year-old target. It's just that we finally learned how to create a composition of matter that has the right pharmacological properties that you could actually drug that in an effective way. The Alzheimer's drugs, the one that's been approved and the one that's on the cusp, amyloid beta, both of them, not novel targets. So what we are trying to do is not to compete with those companies on making those drugs against those targets better. They do that pretty well. What we try and do is, and Paul mentioned that in his introduction, take an unbiased view of the data that we can collect from biological system and listen to the biology when it talks to us. So let machine learning listen for us, because we as human minds are unable to assimilate the complexity of human biology and disentangle the threads in it. We need AI to do that for us. And we take a deliberately unbiased view that says, we're not going to come in with preconceptions of this matters and this doesn't. Not only at the level of targets, but also at the level of what's being measured. The focus of everything we've done has been, as much as we can, rely on data that is as unbiased as you get. So we don't take pathologist annotations of histopathology slides from tumor biopsy samples. We look at the raw images, and we let the machine tell us what it sees and what is important, specifically so that we can move outside the boundaries of where people have typically looked to where they haven't looked, what they haven't seen, which gives us new threads to pull on, which will hopefully give us the next generation of drugs.
Fantastic. Thank you, Daphne. Paul, over to you.
Let's see. Yeah, so what we want to do here is go to audience Q&A. Questions from the audience.
So, the field is moving super fast. And so I think what one needs to develop as an incomer into the field, the newcomer, is really agile learning skills and the willingness to not get too hidebound and too attached to your favorite technology. So willing to be questioning, seeking, and so on. So basically an agile mentality. And the other, which is a skill that I think will be important into the very distant future, even as computers become better programmers than we are, is structured thinking skills. Because today, you can't take an ill-defined, sort of amorphous, murky thing and tell whatever Copilot to solve, or ChatGPT for that matter, to solve it for you. You need to break it down into its constituent pieces and kind of walk the machine through helping you solve the pieces one at a time. I think multidisciplinarity is a hugely differentiating skill in this ecosystem. It's very hard to find someone who has actually done the work of learning two disciplines and bringing them together. So what I've found is that it's really helpful to have a few of those to nucleate the organization around. And then what you end up is surrounding them with people who are more domain experts on one side or the other, and they kind of help play the translator. Over time, people learn more of each other's jargon, and so people kind of move towards the middle. But you need a few of those cross-functional people at the nucleus of the organization to bridge what is initially a huge chasm in terms of not only jargon, but also mindset. If you think about how scientists, for example, just going back to this discipline, scientists think about the world and how engineers think about the world, it's very discrepant, not just in the jargon. If you're an engineer, you're looking for the patterns that explain as much of the data as possible so that you can make good predictions about what's going to happen. If you're a scientist, oftentimes your goal is to identify the outliers, the things that are the weirdnesses, the things that don't fit, because those are oftentimes the end of the thread that if you pull on, it will give rise to a whole new scientific insight that no one ever anticipated. So people think about the world very differently. Neither of those is wrong. They're both valuable, but bringing those two mindsets together is really hard. And so if you have someone who can kind of bridge, it's really valuable. So if you can train people to fill that niche, they will be an incredibly valuable commodity. So we definitely, so yes, we put these people on teams. I wish we had more of them because
Sure.
I would put 2 of them on every team, but we don't have enough. So we kind of multi-purpose them. They end up being highly overworked. And then, no good deed goes unpunished kind of thing. But yes, so we do try and create a broader sort of cross-disciplinary dialogue by teaching people the language of the other. So for example, our lab scientists often take our compute people on lab tours and actually walk them through, this is how we do our workflows. This is not because they expect our computational people to, go in the lab and actually do lab work. They had me do that once. It was a dismal failure. I think I ruined more pipette tips in an hour than typically we waste in like a week. So, they never did that again. But I learned something about what the work actually looks like. Conversely, we have an internal course that we teach of Python for life scientists. The one skill that is most important, maybe 1.5. I talked earlier about, the ability to, take a complex amorphous problem and break it down. I think that's just a critical skill for anyone at any level in any job, especially in the day of AI, where, AI is going to do the mundane stuff for us, and so we really need to be able to elevate ourselves. But if I had to say for the career path that I've taken, it's the ability to admit that you don't know and that you're not the expert and that you are willing to ask other people, synthesize information that you get from other people, and be willing to recognize that the decisions that you've made in the past might not have been the right ones and pivot. And I think the ability to admit to being wrong and that you're not always the smartest person in the room is one of the skills that is hardest for people to learn. And I think it's one of the most critical for building a world in this day and age.
I feel like we could talk for hours, but we're only scheduled to talk for an hour today. So Daphne, thank you so much. I'd like to sort of, on behalf of the whole crowd, sort of thank Daphne for her time and being so generous to CDP Investment Board. I think we all learned a lot. So thank you very much.
Thank you.
Thank you.
It was great.
Thanks for coming.